In this video, we will learn how to graph a quadratic function written in intercept form and then take time to identify all of its key components. So on the screen here you can see intercept form in general, and how this typically looks is we have y equals a is some coefficient out in front if there is one, otherwise it's by default just 1, and then you'll notice that there's no x squared here, but instead we have x minus p times x minus q. And these p and q values actually represent something really important on our graph. So what I want you to do here is look at this example here. So this is the equation for the graph that we see over here. And so here you can see we have 2 out in front as our a value. And then from here we have x plus 1 and x minus 3. And if you look carefully at the graph, what I notice, and what hopefully you're noticing as well, is here it says x plus 1, and here it says x minus 3. And if I look at the graph, my two x-intercepts are x is negative 1, y is 0, and x is 3, y is 0. So the reason that this is called intercept form is because the opposite of what is in here with x, hence the subtractions up here, the opposite of what is in there, so in this case negative 1 and a positive 3, those represent where our graph crosses the x-axis. So this is called intercept form because essentially in the format that it is written, it gives us those x-intercept values. So we can use the equation to help us find some key information. Now some other pattern that's pretty cool here is that because this quadratic function is symmetrical, this axis of symmetry here is also very simple to find. So if you look here at our axis of symmetry, what you're hopefully noticing is that it is right in the middle of those two x-intercepts. So the easiest way to find the number in the middle is to find the average. So our axis of symmetry for something written in intercept form is really the two values. So here 3 plus negative 1, those two values added together and then divided by 2 to find the average. So this becomes an axis of symmetry of x is equal to 1, which we can see is true. We have a line vertically there at x equals 1 that divides that quadratic function or that parabola in half. So here on the screen you can see that we have an equation written in intercept form. We have an a value out in front of a negative 1, and then we can see here that our intercepts are contained here in our intercept form. And remember that this is the opposite. So we have x is 1, y is 0, and x is 7, y is 0. So right from the equation, right off the get-go, we have our x-intercepts, which are 1, 0, and 7, 0. And I can put those directly on my graph. So I have 1 and 7. Then from here, the next thing I want to find is my axis of symmetry. And remember, my axis of symmetry is right in the middle of these two values. So all we have to do to find our axis of symmetry is add those two values together and divide by 2. So 1 plus 7 is 8, divided by 2 is 4. So our axis of symmetry here is x is equal to 4. So that's where the middle of my graph is going to be, right in the middle of those two x-intercept values, because this is a symmetrical graph. Then from here we want to find our vertex, and this is going to take a little bit of calculating on our part. So we know that the vertex occurs when x is equal to 4 because the vertex and the axis of symmetry share that x value. So what we're going to do is we're going to take our equations. We have y equals negative 1, and we're going to put 4 in here. So it would be 4 minus 1, which is 3, and 4 minus 7, which is a negative 3. So I have a negative 1 times 3 and then times a negative 3. So those three numbers multiply together. Negative 1 times 3 is a negative 3. Negative 3 times negative 3 is 9. So here I can see I have a vertex at x is 4, y is 9. So there's my vertex point up there. Now with intercept form, you can create a table if you want, but you really don't need to. Here we can see 3 points on our graph pretty clearly. So as a result, I can just connect these points and draw the rest of my parabola. So you can see that right there. So now from here, all that's left to do is identify the key components down below. So I notice I need to find my y-intercept, And I remember that my y-intercept occurs when x is equal to 0. So I'm going to need to calculate that, and I'll just do that down here below. So I have x is equal to 0, so I'm going to have y is equal to -1, and then it's x minus 1, so 0 minus 1 is -1. And 0 minus 7 is a -7. So if we multiply those together, -1 times -1 is a +1. +1 times -7 is a -7. So where my graph was crossing right about here for the y-intercept before my pen gave out on me a little bit, that is the correct y-intercept. We can see we estimated that pretty well. So our y-intercept is that x is 0, y is -7. Then from here, we're going to find our domain and range, and my graph is going forever to the right and forever to the left, so I know my domain is all real numbers. I then know that my range starts at 9 and goes down, so that's y is less than or equal to 9. I can also see that my vertex is a maximum point because it is the highest point on that particular graph. And then the last thing here is to find my increasing and decreasing. We read this left to right, just like we read a book. So I can see I'm increasing here. I'm increasing here to the left of x equals 4, which means I'm increasing when x is less than 4. And then I'm decreasing, I'm going down as I am to the right of x equals 4, which would then be x is greater than 4. So here again I have intercept form, and this intercept form might look a little bit different to you, but this really is intercept form even though it doesn't have the 2 parentheses. So here we can actually rewrite this function to be y is equal to, the 3 is our a value out in front. This x value here is really surrounded by parentheses and has an x plus 0. We just didn't write that in originally because we don't really need that value in there. And then we have x plus 6. So when you have just an x value out here by itself right next to the a value, whatever it may be, that's really implying that we have an intercept, an x-intercept of 0. So you can add that x plus 0 in there if you would like. So it will help you remember that you have x-intercepts occurring here. Here we have 0, 0, and here we have -6, 0. So remember, it's the opposite of what we find inside of these parentheses. So we have 0, 0 is our first, and -6, 0 over here. So then from here, we need to find our x-intercepts and label them. So here we're going to label them down here. And then we need to move on to find our axis of symmetry. And remember, our axis of symmetry is calculated by taking those 2 x-intercept points and averaging them. So in this case, we're going to get 0 plus -6, which is -6, divided by 2, which gives us -3. So here we have our axis of symmetry right here at -3. So we have x equals -3. And then from here, we can move on to find our vertex. And remember, our vertex and our axis of symmetry share an x value. So here we're going to calculate when x equals -3, what y would be. So we have y equals 3 times -3 times, well, that's -3 plus 6, so that would be 3. So here we have 3 times -3, which is -9. -9 times 3 is a -27. So some of you might be thinking, this doesn't quite fit on our graph. You're correct. So we're going to have to kind of estimate here, and it looks like -27 is going to come all the way down here. So it's going to come down pretty far. So I'm going to kind of estimate that here. It's not going to be perfect, but we'll make it work just the same. So if you get something that's really far off the graph, you can make a little sketch there. It doesn't need to be perfect. We're just trying to see where our vertex is, which in this case is -3, -27. And then from here, trying to get a good estimate of what our graph is going to look like. So the next thing here is we need to identify our y-intercept, which luckily we can see on the graph is right here at 0, 0. I can also see that my domain is all real numbers because it's going forever to the left and forever to the right. My range is going to be y is greater than or equal to that low point of -27. And as a result, I can also see that my vertex is a minimum point down there at negative 27. The last thing I need to do here is find my increasing and decreasing areas. So we're increasing over here to the right of negative 3. So we're right of x equals negative 3. So that's when x is greater than negative 3. And then we're decreasing over here to the left of x equals negative 3, which is x is less than negative 3. So here we have a complete graph. We started by identifying our x-intercepts, use that to help us find our axis of symmetry, and because of intercept form, we already have 3 key points, so we don't need to do a table of values unless we really want to.